Hello everyone and welcome back. In the previous video, we started with the EDA process. Now, EDA as a part of the project can take a long time. So please take your time if you want to understand the data set. Start with the analysis. We've done a lot of the analysis that needs to be done to proceed with it. But now it's time to create our first component, which is data cleaning. And data cleaning needs to be done after we understand the data point that we have. So when you open data cleaning under 2, you already have Conda YAML file implemented and MLproject. Then you have this data cleaning.py that you need to fill in. Now, your project will have the name that you choose. The name is data cleaning. And here you have 2 pre-made functions, load data and save data. Now, please don't change the save data since it will generate one file that we need to use. And then you have this load data that you need to modify by adding your name of the project. In my case, it's test 515. Now, in your case, it might be differently. The other aspect that might be changed is this, original data. So in my case, it's original data without .csv, and you can check it by going to the project and going here, original data. So you don't see this .csv. And the other aspect is the name of the file that you've pushed to the weights and biases. In our case, it's balanced dataset, since that's something that we loaded from the GitHub repository. Now, if you change the name, use the name that you changed. If you didn't change anything, you will have this balanced dataset as I have it in here. The save data will stay the same for all of us. And then we have this clean data function. It starts by defining Imputer. This will handle the missing values. Now, we don't have any missing values. This is just for an exercise. And we need to save that. So why we are doing this is any processing that we do on top of our data needs to be replicated later down the road in production. So if you're scaling the data or imputing with missing values, you need to do that as well in production. In production, it might be already fully in place with all the data provided to us. That's why Imputer will have no job there, but you still need to handle it. Thus, we need to save it in production environment. Then the next step is to handle outliers. This is the outlier detection or handling process. If you don't know why it's done in this way, please refer to the link with amazing read in the description of this video, where I'm going to provide the amazing read on this formula, and you can learn more about it. We removed all the missing values or all the outliers. We need to save that. And then we are doing StandardScaler. We need to save the scalar data and the scalar itself, as well as adding that fraud back to, or fraud column or target column back to our data set as well. So all of that is done in this clean data function. Okay, so the first step for us is to handle the missing values. Now, we are using the simpler imputer that uses median of the column to fill in the missing values. This is not a scalable or solution that is done all over the place in production. Sometimes it is. It's a really, really common, but it's not one size fits all. Then we have the numerical data we are using to indicate by mp.number. We are filling that and using the column names of the column of numerical data. And after you fill in that, you need to create an artifact that will be basically that artifact use impute data, but we are actually saving the imputer itself. So what I want to do is remove all of this recommended for me and say imputer, and type is model. And here we need to have my imputer saved. Okay, so because we don't have this saved, what I'm going to do is use joblib.dump imputer into imputer.ptl. And this will be my path and adding the artifact, and I can just remove this log. With these 4 lines of code, we save the first model inside of our weights and biases project. After we have that, it's time to proceed to the next step. So we handle dataset, we have this imputed data, we are performing our outlier dissection, and now we have to log outlier remover stats. So just to know what actually happened. So what I'm going to do is use this log.outlier removed, and outlier removed is this one that I'm going to log. After that step, we logged all the information necessary for us. It's time to log the feature scale stats. And that can be done with this. So we are using scaler.getParams to get the means and all the ways that we actually scaled our dataset per column, because it actually looks each column independently. And after that, I need to save the scaler as well, because it actually works the same way as the imputer. So what I'm going to do is create the artifact to use and save the scaler model, scaler.pkl, and log the artifact to our production. At the end of the day, we need to bring it back to the features and the column that we are trying to predict, which is our isFraud, and we are returning the scale data down the road. Here, you can see that we are logging the clear data, saving that clear data to weights and biases using this save data function, and we are logging everything in the MLflow and ending the run with MLflow. So in this case, we don't have much to do with MLflow. We are creating the component that can be run in sequential order, but in this case, the most functions and the most things are done using weights and biases. Okay, so please make sure that you are using your username here, the name of the project you choose before, and this is one of the most common things where the error might occur, where you are naming it in a way that you actually didn't save it in a weights and biases. If everything works as correctly and you implemented your whole component, you should go to this exercises folder and run MLflow run to data cleaning. You will find this run command in the description of this video. So please use that, and the running of the ML component will happen. So the first is to install everything as a channel and as a Conda environment, and everything will be executed for us. Okay. So after that happens, we'll have all this data processed and saved inside of our MLflow and weights and biases project independently. So let's wait for the execution of this, and I'll see you when everything runs. Okay, great. If everything ran as correctly as possible, this is some kind of a log that you would get. Let's go to weights and biases account and check our runs. You will see that there is a new run, or multiple runs in my case, for data cleaning. And you will see that, for example, for artifacts, there is original data that I used, and the output is imputer, scaler, and process data. When I go to processdata.csv, okay, and check the lineage, you'll see that, for example, we had EDA ran, then we ran that on original data, cleaning ran, and then we generated the artifact of processdata.csv. So we got actually the lineage of where it actually came from. And that's the power of weights and biases. Now that we are using and stacking together the same set of components on top of our data points, this is where to get. You can check, for example, all the runs in here, and under each run, you will find, for example, the stats for outliers removals and stuff that can't unfortunately be visualized in here, but everything is under the same run.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.